So this section is about physical and chemical changes and about physical and chemical properties. So when we talk about a physical change, that's changing the state, meaning a solid, liquid, or gas, or the appearance of the substance, but we're not actually changing what it is. Like if you take a piece of wood and you cut it in half, you've changed how it looks, you've changed how much it weighs, because you've got half of it now, but it's still wood, right? So that's a physical change. So when we look at, say, this water that's boiling, and if we could zoom in, we'd see these little, don't they kind of look like little Mickey Mouse heads? These little water molecules. When the water boils and goes from a liquid to a gas, those individual molecules do not change. They stay the same. It's just how far apart they are and how they're interacting with their neighbors. Okay, so that's a physical change. The atoms or molecules do not change. In a chemical change, the atoms or molecules do change. And so in a chemical change, the original substance gets destroyed and a new substance is formed. The example here is the rusting of iron. So here we have an iron nail, and the iron itself is just iron atoms arranged in a nice little pattern here. When the iron rusts, it combines with oxygen to form iron oxide, which is rust. It has a different color, it has different texture. It's not strong, it's flaky, it falls off. You wouldn't want to build a bridge out of rust, right? It wouldn't hold together. But iron might be good. So chemical change, the matter is changing. Now the atoms themselves aren't, because they're like the Lego blocks, right? And we're just putting them together differently. But here we're adding a different kind of atom in here. And so this is a different substance than we started with. Some more examples. Here we have an illustration of dry ice and a picture of dry ice. Dry ice is carbon dioxide in the solid state. Carbon dioxide is really strange because it does not exist as a liquid at atmospheric pressure. And that's why they call it dry ice, because it doesn't get your food all wet, right? Regular ice melts and your sandwiches get soggy in the cooler. Dry ice doesn't melt. It does what we call subliming. It goes straight from a solid to a gas, which is really kind of weird. But we see the same little molecules here and here. It's a physical change. Anytime we're changing state, melting, freezing, subliming, whatever, it's just going to be a physical change. Another physical change that's not as obvious is when something dissolves. So here we have an illustration. Here we have an example of a physical change known as dissolving. So here we have an illustration of sugar. These are sugar molecules. And you put some sugar into a cup of water and you stir it, and what happens? It dissolves. It looks like it disappears, right? It's like, where did it go? Well, it's inside the water, but you can't see it, but you can taste it, right? And so what happens here is that the sugar molecules just become separated from each other and mix in with the water, but these molecules are unchanged. And so this is also a physical change because the molecules are not changing. Here's another example of a chemical change, burning propane. So propane gas looks something like this, and you can buy it in these little tiny cylinders for camping or the big ones for your backyard barbecue. And when you burn this, it combines with oxygen and turns into other things, right? So this molecule becomes these molecules when it combines with oxygen. So instead of having propane, now we have carbon dioxide and water. So the original molecule is not there anymore. This is a chemical change. Okay? Anytime it mentions burning or combustion, that's a chemical change. Then we can talk about properties. A physical property is one that the substance displays or that you can observe without changing the substance. So if you have some gasoline and you waft it, like the guy in the video, instead of being ridiculous and snorting it up your nose, if you waft it and you can smell it, it has a distinctive smell. Does the process of smelling the gasoline alter the gasoline? No, it doesn't. Other examples besides odor, taste, don't taste the gasoline, color, appearance, melting point, boiling point, and density. We can measure these, observe these without changing the substance. A chemical property, on the other hand, can only be observed when the composition changes. So basically, chemical properties are descriptions of chemical reactions, of chemical changes. So gasoline we know is flammable. So when you demonstrate that and burn some gasoline, do you have gasoline left? No, you've destroyed it. That's a chemical change, and so the burning of gasoline is considered a chemical property. Others are corrosiveness, acidity, and toxicity. So there'll probably be a question or two like this on the first exam. Determine whether each change is physical or chemical, and then what kind of property is demonstrated in each case. So here we have a copper wire is hammered flat. What we want to think about is the copper, is it still copper or has it changed into something else? It's still copper, right? So physical change or chemical change? That's going to be a physical change. Now, that property that you can hammer a wire into a flat piece of metal, is that a physical property or a chemical property? That's a physical property. So it's physical for both, right? Letter B. Now this one's a little bit tricky. A nickel, like the coin, dissolves in acid to form a blue-green solution. That's a chemical change. The word dissolve there might make you think, well, sugar dissolving was a physical change, right? But it's forming something different here. The color's changing, right? And that's one of the things that we sometimes observe during a chemical change. So this nickel dissolving in acid, it's reacting with the acid and forming something new. So that's a chemical change, and that description is a chemical property of nickel. Dry ice sublimes without melting. Physical. I'm not sure why they put that on this question because we just had a slide where we talked about that, but that's just a state change, going from a solid to a liquid. So it's a physical change and a physical property. A match ignites when struck on a flint. Chemical. Because after you light a match, is it the same? No, you light it once and that's it, right? Because when you light it, a combustion chemical reaction occurs and destroys the original substance. So that's a chemical change, and the fact that matches ignite when struck on flints is a description of a chemical property. Any questions?
So for chemical changes, you would normally need more energy to make it happen.
Oftentimes chemical reactions do involve energy. Sometimes it releases energy, sometimes it requires energy. But then physical changes can also require energy. So if you think about melting an ice cube, that also requires energy. Yeah. So here the diagram on the left represents liquid water molecules in a pan. And which one of these, A, B, or C, best represents the water molecules after they've been vaporized, turned into a gas? A. Oops, wrong place. Because when this goes from a liquid to a gas, the particles don't change, right? And so these are the same little things that we had over here. Here they've recombined into different kinds of molecules, and there they've all separated into individual atoms. So if either of these occurred, that would be some sort of a chemical change. Any questions?